I will create a new verilog. Decoder 2x4. Decoder 2x4. How it will look like, decoder, how it will look like. We will see first. You can see this is the decoder, 2 inputs and 4 outputs. Inputs are AB, outputs are D0, D1, D2, D3. Because inputs AB, 2 inputs are there, 4 combinations. Output you can see when both are 0, 0, output D0 will become 1. When it is 0, 1, D1 will become 1. When it is 1, 0, D2 will become 1. When it is 1, 1, D3 will become 1. Okay. So now, if you write equation for D0, A bar, B bar is there. When you write equation for A1, A bar, B is there. Then D2 means for D2 equation, if you write A into B bar is there. Then D3 means A into B is there. Okay. So these are the equations. You can see here A bar into B bar, A bar into B bar. So I can also write it as A plus B whole bar. Okay. So A bar into B bar, I can also write it as A plus B whole bar. So in that case, A plus B whole bar means it is NOR gate. It is NOR gate. This is D0. You can see this circuit. This is a NOR gate circuit. If I give A, B as inputs, output will come A plus B whole bar, which is A bar into B bar. Okay, which is A bar into B bar. So similarly, the second equation, A bar into B. So what I have to use as inputs if I am using a NOR gate. So A plus B whole bar if I use. A plus B bar whole bar if I use. Okay. So A plus B bar whole bar if I use. This is D1. Okay. So A and B bar I am giving inputs. Output will become A plus B bar whole bar. Then when you apply De Morgan's theorem, A bar into B will come. A bar into B will come. So second one output is A bar into B. Okay. So like that I am going to use 4 NOR gates. 4 NOR gates. Appropriate output equation I will get it in the NOR gates. So these are the design. These are the design. This design is for D0. This design is for D1. This is for D2. This is for D3. And the intermediate variable, red color I have written. At this point, I am considering the variable A1. At this point, A2. At this point, A3. And at this point, A4. Okay. So these are the 4 circuits I have for creating the outputs of decoder. 4 outputs of decoder. D0, D1, D2, D3. Okay. So now I have created a program file, verilog file. Now I will execute the decoder 2x4 decoder in switch level modeling. 4 NOR gates I am using. 4 NOR gates I am using. This is the last program. Once completes, we will close the lab. You can relax. So this is about D0. You see here D0, 2 PMOS transistors, 2 NMOS transistors. Okay, for D1, 2 PMOS transistors, 2 NMOS transistors. For D2, 2 PMOS and 2 NMOS. For D3 also 2 PMOS, 2 NMOS. I am naming this as PMOS 1, PMOS 2. This as PMOS 3, 4. This is PMOS 5, 6. This is PMOS 7, 8. Similarly, NMOS also 1, 2, 3, 4, 5, 6 and 7, 8. You see the coding. First I have used PMOS 1, 2, NMOS 1, 2. This is for D0 output. Then PMOS 3, 4, NMOS 3, 4. This is for D1 output. Then PMOS 5, 6, NMOS 5, 6 for D2 output. And PMOS 7, 8 and NMOS 7, 8 for D3 output. Okay, the last circuit. Now, what are the inputs I have to give? If I concentrate on the first circuit, first PMOS inputs are VDD and A. Okay, output is A1. Output is A1. You can see VDD, A are the inputs. Output is A1. Now I am going to second PMOS. Second PMOS inputs are B A1. Output is D0. Okay. So B A1 and output is D0. Now I am going to NMOS 1. This is NMOS 1. Inputs are B and ground. B and ground. Output is D0. Okay. So B and ground. This one. B and ground are the inputs. Output is D0. So next one more thing is there, A and ground is there. and output is D0. I can name this as P3, N3 or this as N3, no problem, no. So here A and ground are the inputs, D0 is the output. So A and ground are the inputs, D0 is the output. So first circuit completed, first NOR gate circuit completed. Now I am going to second NOR gate output, D1 will come. Second NOR gate, D1 will come, this circuit. So first PMOS, VDD and A are the inputs. VDD A, then A2 is the output, okay? So VDD A, A2 is the output. Next, second PMOS, A2 and B bar are the inputs, D1 is the output. A2 B bar. A2 B bar are the inputs, D1 is the output. So next NMOS, this NMOS, B bar and ground. B bar ground are the inputs. Here A ground are the inputs. B bar ground, A ground. Both of them D1 as the output. So both are giving D1 as output. So B bar ground, A ground. These are the inputs. Okay. So second NOR gate circuit completed, where we will get D1 as output. Now third NOR gate. This is the third NOR gate. So here PMOS. For PMOS, we are having VDD and A bar. A3 is the output. So here you can see VDD A bar, A3 is the output. So next PMOS, A3 and B are the inputs. A3, B are the inputs and D2 is the output. So here you can see output is D2, A3, B are the inputs. Next, two NMOSs are there here. Both of them, one of the input ground, other output is common D2 and other input is B, A bar. Okay, B, A bar. You can see here D2 is the output, both the cases. Ground is one of the input, B and A bar. B, A bar. Okay, so third NOR gate completed. Next, last one for PMOS, VDD and A bar, output is A4. Output is A4, VDD, A bar are the inputs. So next PMOS is there, B bar, A4 are the inputs. B bar, A4 are the inputs. Output is D3. Okay, so output is D3, A bar and A4 are the inputs. So next two NMOSs are there. Both are giving output D3. Both of them, one of the input is ground and other input is B bar, A bar. Okay. So here you can see both are giving D3 as output. One of the input is ground, A bar as another input, B bar as another input. All the 8 PMOS, 8 NMOS, the definitions I have given. Okay. So next what we are doing, the general thing, supply 1 means VDD, supply 0 means ground. Then all the intermediate variables in the diagram, red color I have written A1, A3, A2 and A4. All this I have declared as wires. And A bar, B bar, these are intermediate variables. So using NOT gate, I am preparing them. They will act as output as well as input at appropriate times. Okay. So A bar, B bar. If you see, this is decoder. We are executing decoder. Decoder will have only A, B as inputs. A bar, B bar, whenever we give 0, that becomes A bar. And that's the reason in the coding, we are generating this A bar, B bar using NOT gates. And they act as wires, not overall input. Overall input is A, B only. A bar, B bar are intermediate inputs and outputs. So wire. Okay. So we have given complete definition. Now I will go with the decoder, make it as top module. Decoder, make it as top module. Now I have to do check syntax for the decoder, check syntax. Completed. Now I will go with test bench for decoder. With this, we will complete. So verilog test fixture, decoder underscore TB, decoder underscore TB. We are creating for test decoder. And we know in the truth table, only 2 inputs. So we will have 4 combinations. 2 inputs, 4 combinations. I will make the delay as 20. So 0001, 1011. 2 inputs means 4 combinations. Next, $stop. Okay. Now we will select the test bench of decoder, execute. Now, as per truth table, what should come? As per truth table, what is the output? When AB00 means only D0 should be 1. All other outputs are 0. Okay. So AB00 means only D0 is coming as 1. Okay. Now AB01 means only D1 should come as 1. Now for the next thing, AB01, only D1 is 1. Next, AB10 means only D2 is 1. Only D2 is 1. So AB10, only D2 is coming as 1 at the yellow color line. Okay. Next, last case, AB11 means only D3 is 1. All other bits are zeros on the output. So now yellow color line, AB11 means only D3 is 1. All other bits are zeros. Okay. So we have implemented the 2x4 decoder using switch level modeling. 2x4 decoder using switch level modeling. 4 NOR gates we have used. 4 NOR gates we have used. And appropriately in the diagram what we have implemented the decoder. Output equations for D0, D1, D2, D3, 4 output equations using NOR gate we have written in the coding. Okay, 4 NOR gates separately. We got the output as per truth table. Okay, so with this, what all we have done today, now I completed 2x4 decoder in switch level modeling. Okay, so we started with the 2x1 multiplexer, then structural model for 4x1 multiplexer.